substitute a 400, which would be is equals to 800 multiplied by 400 minus 2 into 400 squared, which will give us 0. So therefore, the maximum area that the farmer can enclose is 80,000 meters squared within a field of 200 meters by 400 meters. That's all for quiz 1. Now we'll move on to the quiz number 2. So the quiz number 2 has 3 questions as well, which are: let f of x is equals to x cubed plus ax squared plus 2a squared x plus a, such that the acceleration at x is equals to 2 is 0. So what is the value of a? We'll start with f double prime 2 is equals to 0, which will give us fx is equals to x cubed plus ax squared plus 2a squared x plus a. So f prime x is equals to 3x squared plus 2ax plus 2a squared. So f double prime x is equals to 6x plus 2a. So f double prime 2 is equals to 6 multiplied by 2 plus 2a. So 0 is equals to 12 plus 2a, which will give us a is equals to negative 6. Let's move on to the question number 2. So we'll find the extreme values of f of x is equals to x squared plus 6x plus 9, where the interval is 0 smaller than equal to x smaller than equal to 5. For this, we'll start with the equation f of x is equals to x squared plus 6x plus 9 comma 0 smaller than equal to x smaller than equal to 5, which will give us f prime x is equals to 0. So we'll put that in uh, along with the equation. So 0 is equals to 2x plus 6, which will give us x is equals to 3. Now we'll substitute f minus 3, which will be minus 3 squared plus 6 into minus 3 plus 9, which will give us f minus 3 is equals to 0. So we'll substitute 0. F0 is equals to 0 squared plus 6 multiplied by 0 plus 9, which will give us f0 is equals to 9. Which, and then we'll substitute number 5, which will be f5 is equals to 5 squared plus 6 multiplied by 5 plus 9, which will give us f5 is equals to 64. Therefore, the maximum value would be 64 and the minimum value would be 0. Let's move on to question number 3. Owner of a car rental company have determined that if they charge customers PP dollars per day to rent a car where 50 smaller than equal to P smaller than equal to 200, the number of cars N they rent per day can be modeled by the linear function NP is equals to 1000 minus 5P. If they charge $50 per day or less, they will rent all their cars. If they charge $200 per day or more, they will not rent any cars. Assuming the owners plan to charge customers between $50 per day and $200 per day to rent a car, how much should they charge to maximize their revenue? For this question, we'll start with the basic formula, which is R is equals to N multiplied by P. And so R is equals to 100 minus 5P in the bracket and multiplied by P out of the bracket. So R is equals to 1000P minus 5P squared. And R prime is equals to 1000 minus 10P. R prime is equals to 0. We'll put a 0 in the equation. 0 is equals to 1000 minus 10P. Pardon me. P is equals to 100. So R, now we'll substitute 50 into the equation, which will give us R50 is equals to 1000 multiplied by 50 minus 5 multiplied by 50 squared, which will give us 37,500. So now we'll substitute R100, which will give us 1000 multiplied by 100 minus 5 multiplied by 100 squared, which will give us $50,000. Now we'll substitute 200, which will be 1000 multiplied by 200 minus 5 into 200 squared, which will give us $0. Therefore, the maximum revenue which will be gathered would be $50,000. That's all for quiz number 2. We'll move on to quiz number 3. So the quiz number 3 also has 3 questions, which are pretty simple as of we have learned in quiz number 1 and 2. So let's start with question number 1. Question number 1 says, let st is equals to t cubed minus 12t squared plus 36t minus 20 when is the particle moving to the right and speeding up. So for this, we will start with st is equals to t cubed minus 12t squared plus 36 minus 20. That is the basic equation. Moving to the right, s prime t is greater than 0. So s prime t is equals to 3t squared minus 24t plus 36, which will give us 3t squared minus 24 plus 36 greater than 0, which will further give us t is equals to 6 and t is equals to 2. Now we'll speed up to s double prime t greater than 0. So s double prime t is equals to 6t minus 24. 6t minus 24 greater than 0, which will give us t is equals to 4. Moving on to question number 2. Find the extreme value of f of x is equals to x cubed plus 6x squared minus 96x plus 23. So we'll start question number 2 with the basic equation, which is fx is equals to x cubed plus 6x squared minus 96 plus 23. So f prime x is equals to 3x squared plus 12x minus 96. We have a basic f prime x is equals to 0, which will be put into the equation along with the other numbers, which is 0 is equals to 3 bracket open x squared plus 4x minus 32. 3 is taken as a multiple, which will give us x is equals to minus 8 and x is equals to 4. Furthermore, we'll substitute minus 8 into the equation, which will give us f minus 8 is equals to minus 8 cubed plus 6 multiplied by minus 8 squared minus 96 multiplied by minus 8 plus 23. So f negative 8 is equals to 663. Now we'll substitute f4, which will give us 4 cube plus 6 multiplied by 4 squared minus 96 multiplied by 4 plus 23. Pardon me. F4 will give us minus 201. Therefore, the maximum is 663 and then minimum is minus 201. Let's move to the question number 3. Suppose the population is in thousands of certain species of insect after t months is described by the function pt is equal to 4t plus 100t over t squared plus 400 plus 500 plus 500. Determine the maximum population in the first 3 months. We'll start with the basic equation, which would be pt is equals to 4t plus 100t over t squared plus 400 plus 500, comma 1 smaller than equal to t smaller than equal to 3. P prime t is equals to 4 plus 100 in bracket open t squared plus the 400 bracket close minus 2t multiplied by 100t over t squared plus 400 squared whole squared. P prime t is equals to 0. So 0 is equals to 4 plus minus 100t squared plus 40,000 divided by bracket open t squared plus 400 bracket close whole squared. No critical number is attained. So P1, so 1 will be substituted into the equation, which will be P1 is equals to 4 multiplied by 1 plus 100 multiplied by 1 divided by 1 squared plus 400 plus 500. So P1 would derive 504.249. We'll substitute number 3 into the equation, which will be 4 multiplied by 3 plus 100 multiplied by 3 over 3 squared plus 400 plus 500. P3 would give us 512.733. Therefore, the maximum population is 512